Hello YouTube, XCT here. In today's video we are solving Serial, a 40-point machine on HackTheBox. For user, we will exploit a pretty tricky deserialization vulnerability in a .NET web app. For root, we will use impersonation to elevate privileges. So after the initial port scan, we can see that we have SSH, we have port 80 and 443. So let's look at these websites. There's serial.htb, but it's just this login form, and looking at the source doesn't show too much either. So let's have a look at the nmap output again. And here we can see that from the certificate, nmap found that there's also the source.serial.htb. So let's have a look at that one as well. I already added it to my hosts file here. And here we get some error. You can see it's a .NET C# application, but other than that, there isn't too much here. One thing to note and to keep in mind for later is that we have some kind of disclosure here, so we know where the web root is. All right, since these websites don't give us too much yet, let's do some directory fuzzing. On one hand, we do it on serial.htb, and on the other hand, we do it on the source.serial.htb side. And let's stop that down here. We found a .git directory. This is interesting on the source side. So what we can do usually when we find such a Git directory is we can use Git tools from Internetwache to dump the Git repository. So let's do that. So we use this git dumper.sh script, just give it the URL and it will dump it to a local directory of our choice. So let's call that dump here. So the dump is complete. Let's look at the directory. And there's actually nothing here. So let's check the git status. And we can see that all these files have been deleted. So let's just restore them. This is my shell acting up. So let's just go to bash real quick here and then restore it. Check the files again, and now we can see that all the files have been restored, and we basically have the source code of some web application here. So let's actually now explore the application. And I always like to start with the controllers because there you can usually see what kind of ways exist for user input into the application. So let's look at the requests controller first. And there seems to be some endpoint where you can post, as we can see here. And in order to do that, by the annotations, you can see that you need to be authorized here. And if we post to the endpoint, we don't know the exact URL yet. Let's just look at the method for now. If you post it to this endpoint, you will be able to add something to a database. This is pretty interesting. And if this works, there will be this great serial request message. So we have some way to create stuff in a database. This is pretty interesting. And if we look at the method down below, we can also retrieve something from the database by the ID. And on creation, we get the ID. Here we can use them to retrieve it again. And if you retrieve it, as you can see here, whatever is stored in the database will be deserialized. And there are a few things here that are interesting. First of all, there's this filter to prevent deserialization attacks, which is a pretty big hint at what we want to do. And we can see that this filter blocks certain keywords like object data provider, Windows identity, what's the last one, system. So we have to build a payload without these. And these are specifically chosen because they occur in WISO serial default payloads. And one other thing that is interesting here is that there's this annotation which says that the policy is restrict IP. Judging by the name, probably only certain IPs will have access. And this usually means on these boxes that the request has to come from localhost, but we can verify that. Let's look at the rest here first. This is under restrict IP2. This just shows all stuff that was stored in the database in the reverse order. So basically the newest one is at the top. And there's also a function to delete some stuff and to delete everything. So let's actually try to find where this restrict IP thing comes into play here. So we search for that in all the files. And there's the startup.cs, where this is added as a policy, and it's coming from the application options. So basically we have to figure out where these options are in the end coming from. And here we can see this app settings.json file being mentioned. So let's look at that one. And here are some options that look interesting, right? There's this whitelist, which looks like the restrict IP thing we saw earlier. What makes sense, or maybe it's that one. I'm not 100% sure, but it's the same value. So basically it restricts requests to everything coming from localhost. And there's IP rate limiting and just an allowed hosts list, right? So in order to, let's get back to the request controller, to create something here, we need to be authorized. That's okay. We don't have to come from localhost for that one. But in order to trigger the deserialization, to retrieve the item from the database, we would need to be coming from localhost. So we're probably looking at some kind of SSRF here. So there's another controller here, this users controller. And this is probably what's handling the authentication. So if we look back to the original web app, there was this authentication form here, right? So this seems to be the controller that's handling that. Let's look at the other files here. There's also this download helper. So basically these kind of boxes and CTF terminals in general often have some kind of helper to assist you with such deserialization attacks, especially if you are blocked from the default payloads. It makes absolutely sense. And the way this class works is that if you deserialize it, it will execute the download method, which will download from the URL and place it somewhere on the box with this number as a prefix. So we can use that later on if we figure out how to trigger all the stuff to upload a web shell, probably. So let's continue looking at stuff here. There's this user service, and this is actually handling the authentication. So let's have a closer look here. We can see that JWT tokens are used, and the key seems to be not visible here. So that's a problem, because in order to generate a valid authentication without knowing the password, we would need to know this key. But remember that we are in a Git repository, so maybe someone deleted the key. Let's look at the Git log here. And let's just check out the very first version. And now we have the actual secret here. So let's store that. Now what we have to do is basically run this token generating code to obtain a JWT token so we can log into the application. And you can either copy this in a new C# project on a Windows VM or whatever. I'm going to use .NET Fiddle here because it's a bit easier and we can do it in a browser. So this is basically just the copy-pasted stuff from the file here. With one addition, I know that the username is Sonny here. Sonny is basically the username that's occurring all over the Git log as an author. So we'll just use that. We can run it and generate a JWT token here. So let's actually try to use the token somewhere. If we just go to requests here, see that we get an unauthorized error. Let's send that to the repeater and try that with the token. And now we get forbidden and no longer unauthorized. So that's some progress. Let's look back at the controller for a second. So just going to request is basically this get all route here. And we can see that that this requires the restrict IP policy. So that's probably the reason why we get the 403 error, right? But this one up here, which is just a post to requests, should actually work for us. So let's try to change the request method. And now we get an unsupported media type. This is expected because we have this content type here, and actually because it expects JSON, we have to set it to application JSON instead of that one. And now we get another error, batch request. We need some body. Let's try to send it like that. A JSON field is required, and this literally means a field called JSON. And this seems to have worked because now we get a great serial request message, which is this message down here in the method we were targeting. So this was actually now added to the database. But we have one issue. Let's send it to the repeater again, change the request method back. And we saw the ID was 11 just in the request here. So now we basically want to retrieve that to trigger the deserialization, right? But this doesn't work because we are not coming from the local IP address. So let's investigate a bit more. There's also this models folder, and there's a serial model. And this is how the items stored in a database are supposed to look. We have a title, we have a flavor, color, description, and we should set these. There's also this request model, which has request ID and JSON. And this JSON field we've just set, but request ID we didn't. But it appears it was really required because it just gave us a request ID in the response. So now we have to think a bit more on how this all works. One thing we haven't looked at yet is this client app up here. And this basically suggests that an administrator is interacting with this application and he's not using the browser, but instead he's using this client app to interact with it. And if we look here a bit, there's this admin page. So let's make that a bit bigger. And here in this admin page is basically displaying all the stuff we've stored in the database. And if we look a bit at the code here, there's this markdown preview thing, which is a bit suspicious because the title is with this markdown preview displayed, which is certainly a bit special because down here it's just displayed as text and not as this markdown preview thing. Let's have a look at what this actually is. Here in the imports we can see this comes from React marked markdown, and if we look in package.json we can see the actual version that is used here, which is 1.4.6. So let's look for that one. And if you Google for this version, you will find that there's a cross-site scripting vulnerability for this exact one. So try to find out what this is about. And it seems that in the exact same setup we have, same version, same tag with the sanitized true, like we have here. This is exploitable by giving it this JavaScript stuff inside the value. So let's think about the XSS payload now. So in this client app, there is this authentication service, and this is basically executing when the admin is using the client app to connect to this web app. And after authenticating, we can see that the JWT token is stored in the browser's local storage under the name current user. So it would be really cool if our XSS payload would allow us to read this one from the local storage, right? So let's generate a payload for that one. So the payload will basically look like this. We have our request ID and we have our JSON field. And in the title, we have this XSS payload like we saw before. And as the actual payload, we are going to redirect to our box on port 8000. And what we're going to append to the path is the token, which we are going to get with local storage.getItem. So let's start the server here. And let's try to post it here as a payload. And here we got our request. Let's take the token here, copy it, and this is the JWT token of the administrator user, username admin. So now, before thinking about the next XSS payload, the one which will send an authenticated request to our deserialization endpoint, we have to think about our deserialization payload. So let's do that. And I prepared a fiddle here again. Basically, this is the download helper class, just copy paste it into .NET Fiddle. fix the imports, and then at the bottom we have a really short program which just makes an instance of the class and serializes it with some additional options here, which will basically add the type information. The deserialization part will know what class to deserialize. So let's look at the payload. Basically, we want to send it like this. We have some request ID. Let's just call it 1001 here. And it's basically the same payload as above. Just this download helper, I prefixed it with the namespace and added the project name and this version information. I don't think it's really required, but it's something the WISO serial payload said, so I added it here. And for the URL, we are pointing it to our box. Let's use port 8000 here. And we are going to try to upload a command shell, command.aspx. I haven't created that one yet. We'll do that in a second. And the interesting part is where to store it, because this program can't really write anywhere except this path in initpub source here. And where do we know this path from? Well, in the very beginning, we had this error here, and it basically leaked us the path. So this is how we know which one to use here. So let's create a shell here. It's just some default shell I grabbed somewhere off GitHub. So you probably find it if you Google for this Avon ASP.NET Web Shell. We are going to send that and store it in a database. So let's do that. All right, this looks good. And this was stored under 1001. And now we have to basically do the last step. We have to send an authenticated request with the admin JWT token we got here via XSS, because it has to come from localhost. So the final payload will look like that. Let's go through that. It looks a bit confusing. Basically, it's the same kind of payload as before, how we got the admin token, but we changed it up a bit. So we have an XML HTTP request to the ID, which will be 1001 in this case. We have the admin token here. This is the one from the administrator, so let's copy it in here. And we're going to send another request, this time to our box, just to a /proof here. And the whole point of this one is just to give us some indication on when the payload has triggered, because it triggers only so often, and we want to know when it triggered so we can debug if something is wrong with our payload instead of just waiting forever, right? So let me just replace this token here as well. And now this looks pretty good. Let's use this payload. Let's make a new one. Just omitting the request ID here. I'm pretty sure we don't need it. Okay, let's try that. And if that worked, we should in a moment see a request here getting our ASPX shell. So after a moment, we can see that this command.aspx is really downloaded. So let's try to find it on the server. So basically, we expected an uploads and then xct.aspx, but it's not here. And if we look back to our dump and download helper, we can see that before storing it, it's prefixing it with this number. So let's try that. And now the file exists. Let's try to execute the command. And this works, and we got a web shell. One thing to keep in mind here is, didn't explicitly tell this before, but if you do the request to the number where you send your payload, you will have to use HTTPS and not HTTP, because otherwise it won't work. Just a reminder here. So let's go back to the shell. Let's look at C. Look a bit at the web server. There's the source directory. Let's look one back again. Let's look at serial. This is the application. Here we have the database folder, and here we have the actual SQLite DB. So let's just read it here. And here we can actually see our payload because it's stored in the database, right? But also at the very bottom here, we can see the user and his password. And if you remember from the port scan, there's SSH running on the box. So let's try to SSH into the box with this password. And this works. Let's try to grab the flag, and here it is. So to start with the root part, we are going to look at the open ports first. And there's this port 8080, which is listening on all interfaces, but we didn't see it from the outside, so it must be blocked in the firewall, right? So let's forward that to our box and have a look at that. So I'm going to make a port forward here real quick. And if we look at the site, we have this manufacturing plant status. So this is something that was definitely created for the privilege escalation, and we'll have a look at that. And if we refresh that site, we can see that there's a request to this GraphQL endpoint, and it's doing some query. So let's explore that. A good way to explore these GraphQL endpoints is the Altair plugin for Chrome, and we're going to start that one. And basically what this plugin allows is that you give a URL to the GraphQL endpoint, and then you can go to docs here. It will basically give you information about the structure and make it easy for you to construct queries. So let's look at the queries first. There's this all plants thing. This is basically what was automatically requested. So let's try that. You can just click on add query here at the site, and it will create the query for you. So this way we can now enumerate the output of the queries. And if you go back, there are also some mutations, and these are basically methods you can call. And one of them is this update plant method here at the bottom. And this one is a bit special because there's a source URL here. So there's something being done with URL. This is always interesting, right? So let's delete this here and add this function. And it wants some arguments here, so let's just give it some numbers. And as a source URL, let's point it to our box. Start the web server here again. And let's see what happens if we send it. And this seems to be another kind of SSRF thing, right? The server requested this hello endpoint. We gave it in the source URL argument. So we got another SSRF kind of thing going on. And one thing that's important is that if we check who am I all, we will see that we have the SeImpersonate privilege, which is a very powerful privilege in Windows because it allows you in certain situations to impersonate another user. And there are a bunch of exploits for this privilege, like print spoofer or all the potato exploits. But in this case, they all have been blocked by firewall rules, by disabling the spooler, and so on. So we can't really use one of the potatoes that exist. So we have to think about some clever way here. And basically we have this request, and this app is actually running with administrator privileges. We don't know that, we can just assume. And we have SeImpersonate. So what we can do is we can open a web server that is impersonating the user that is requesting the website. And the way we can do this is via PowerShell. So let's look at the script here. So basically we are mixing C# and PowerShell here, but opening a listener and telling it to use the integrated Windows authentication. And whenever a request comes in, we are impersonating the user. And when we have impersonated the user, we basically have his privileges, right? So we can just read the root flag here. You could put any command really here, and you can start reverse shell, start a metasploit, reverse shell, whatever, right? I'm just going to read the flag here because it's the quickest way. I know this code looks a bit confusing. It's based on this thing, which is a NTFS file server, which is using the same impersonation, but it's using it to serve files. And I just reduced it a bit down. So it basically now is executing commands as the user, and all the unnecessary code is basically removed. So let's try it on the target. Let's copy it over with SCP. copy that weird password here. And now we have this file here. Let's start PowerShell and let's execute it. And now we are listening here on the port in the script, which was 9000. So let's do the request here to port 9000, but on localhost, and see what happens. Okay, this doesn't look too good. Let's try localhost instead. And now we got the request. This looks good. We got the impersonation and we got the root flag here. So it's basically over. But as I mentioned, because it is running now at administrator here, you can put any commands here, start a reverse shell, whatever, have fun. If you liked the video, please subscribe, click the like button, and see you next week.